the last lesson of this unit, okay? This is a little bit different so far. Almost everything we've done, but with the exception of variation, it's something that you've probably seen before. Chebyshev's theorem is not, okay? Chebyshev's theorem is a theorem that talks about how much of our data will be within 1, 2, 3, 4 standard deviations of the mean, okay? Meaning we're measuring how far away is our data from the mean. Remember, we talked about standard deviation in kind of an abstract form, saying it talks about how far away it is from the mean. Now, this theorem and the empirical distribution, which we're also going to talk about in this lesson, both are used practically in the education system when we talk about the SAT scores, when we talk about the ACT scores, or anything like the standardized test stuff. When they talk about a student being in the top 1%, okay, they're basically saying that student is more than 3 standard deviations away from the mean score that people get on the SAT. So this has real practical applications to what you're going to be, coming across here very soon as you're taking the SATs and those kind of things. When it gives you a percentage, that's giving you a reference to how well you compare to the middle. Sometimes they don't necessarily use the middle, when they're comparing to the mean. Sometimes they're comparing to other things, but these are the kind of things that we're going to start thinking about with these theorems. So, Chebyshev's theorem. This is really long and detailed, and I'm not going to get into the whole thing, all right, of how the theorem came about and that kind of stuff. If you want to read it, you're more than welcome to. All right. So basically, what this says is we're talking about how far away, if we take a data set that's got 1,000 data points, how much of that data point is going to be within 1 standard deviation of the mean? How much of that data point is going to be within 2 standard deviations of the mean, and so forth. So the one that is the most common is 2, and the Chebyshev's theorem basically says that 75% of all data points will fall within 2 standard deviations of the mean. The empirical rule has a slightly different number, but we're going to use both theorems, and we'll use formulas for both. So what I do want you from this page to write down is the formula to figure out the percentage of the data, or what mean we're trying to get to. K is how far away, how many different standard deviations. So if we want to know how much of the data is going to fall within 3 standard deviations, with 4 standard deviations, and so forth, that is the formula that we're going to use. So let's go ahead, and once you have it written down, we're going to move on to the rest of the conceptual. This gets into a lot of information about Chebyshev's theorem. I don't want to focus on it too much. This is almost the exact same thing that we just looked at. In fact, it might be. I might have double copied. Sorry about that. What I do want you to look at, though, really quick, because the second example is going to focus on this, is, oh, sorry, I just drew a line there. Now it's going to be up here the whole time. Maybe not. Yeah, it will be. It'll be sitting right there. Okay. So the empirical normal rule. So this thing is on that side. The empirical rule is one we use more often than Chebyshev's, but I want you to know both of them. Okay. The empirical rule basically says that 68% of all data points will fall within 1 standard deviation of the mean. Okay. If your data is normal or close to normal. Remember, normal means that it's a bell shape. Okay. I don't even know if it's part of that. Normal is it looks like this. Okay. If you have data that looks like that, or that is uniform, okay, like this, the normal distribution or the empirical rule will not apply. We have to do things to it to make it work. So for a normal rule, 68% of all data points will fall within 1 standard deviation of the mean. 95% of all data points will fall within 2 standard deviations of the mean, and 99.7% of all data points will fall within 3 standard deviations of the mean. So if you are outside of that 99.7%, meaning you are above 3 standard deviations away from the mean, or below 3 standard deviations from the mean, that is a very rare occurrence. It doesn't happen very often. So how can we apply this? How can we make this real in an example? So let's look at an example. Sorry about the line. All right. So using Chebyshev's theorem, we are going to solve these problems we're just going to, again, this is not something we're going to use a whole lot of, but we have this number here that's 80. Okay. So solve the problem for distribution with a mean of 80. So we don't even know what we're dealing with. We have no reference. I don't know what that's doing. We have no reference for, So no reference for what this is or what it's representing. It's just we have a distribution. Doesn't matter if it's a normal distribution or not, we have a distribution. The mean is 80 and a standard deviation of 10. Okay, at least what percentage of values will fall between 60 and 100. So now we're going to use that formula that we just had, okay? And we're going to figure out where is this this standard deviation. So what we want to do is we're going to say, first of all, we need to figure out how far these are away from the mean. So this is, so we go 100 minus 80. Okay. 100 minus 80. Sorry, I just lost my train of thought. This is not a theorem that I use very often. You'll figure that out. These things that I don't use very often, sometimes I have to think about, even though I just thought of them. Okay, so first of all, you need to notice that this data point, 60 and 100, 80 falls directly between it. That's really important, the Chebyshev's theorem, is that when you're looking for percentage of values, that you have these two values that we're looking for, that the mean is directly in the middle of them. Okay? So 60 is 20 and 100 is 20, which means that 20 divided by the standard deviation, that we are 2 standard deviations away. So what is the percentage? Chebyshev's theorem says that if I go 1 minus 1 over 2 squared, okay, which is, this is how many standard deviations away am I from the mean? It's 1 minus 1/4, which is 3/4, and that is 75%. So 75% of all the data points for this distribution, whatever it is, will be between 60 and 100. All right, now let's look at this other one, the 65 and 95. And again, I apologize earlier, I was looking at my notes, I'm not sure where I was. Okay, 65 and 95. So again, we have these data points, 65, 95. Right in the middle of them is my mean, which is 80, is 15. It's 15 points away, so if we figure out how many standard deviations that is, 15 divided by 10, it's going to give me, I am 1.5 standard deviations away. So now I can take this 1 minus 1 over 1.5 squared, okay, and that is going to give me 0.55, which is 55%. So 55% of all data points fall between 65 and 95. So this is kind of a weird theorem. Just use your formulas, and it should work for you. Okay, normal distribution. This is something that we will use. Oh, sorry, I'm not there yet. I'm jumping ahead. Practice problem. Okay, so try this one on your own. So you have, and if you're struggling with it again, this is kind of a weird concept, go ahead, look at the solution and jump back. Otherwise, go ahead and pause the video. All right, here's your solution with all the steps. Okay, so if you need to pause that, go ahead and do that really quick. All right, and moving on. Okay, normal distribution, example 2. So this basically says the average yearly per capita consumption of citrus fruit. So how much fruit do, citrus fruit, which is like oranges and those kind of things, do we eat in the U.S. is 26.8 pounds. Suppose that the distribution of the fruit amounts is bell-shaped, which means that it's normal. Okay, that's what we want. And the standard deviation is 4.2. Okay, what percentage of Americans would you expect to consume more than 31 pounds of fruit per year? Now this is kind of an interesting one. What I'm going to do with this, normal distribution is always exactly the same. I have my mean, right? In this case, it's 26.8. Okay. And then I'm going to go 1 standard deviation away on both sides. So if I go 1 standard deviation away on both sides, I'm going to subtract the standard deviation. Well, and actually, it says I want more than, so I really don't care about below. I'm going to go 1 standard deviation above. So 1 standard deviation above is going to be, if I take 26.8 and I add 4.2, I get 31. Okay? So we know that right here, okay, 1 standard deviation away is 68%. Okay? Which means that this half is going to be 34%. Okay? So we know that 34% of 34% of the U.S. population consumes between 26.8 and 31 pounds But that's not what we want to know. What we want to know is what's this number here. Now we have to think about this chart here and what we're looking at. Right here, okay, if this is 0 and this is 100, this is my 50%. So this whole thing is 50%. So if I go 50 minus 34, that's going to give me this number here. So 50 minus 34 is 16%. So 16% of Americans eat more than 31 pounds of fruit, of citrus fruit per year. Okay? This is probably, I would say, the hardest lesson we've done so far, just because it's kind of abstract, it's kind of weird, it's using a lot of different things, and you have to use your brain to do some calculating on your own. So go ahead and do the next example, or the practice problem on your own. All right, so this one, I ask specifically for you to give me the empirical distribution, meaning I want you to set up the chart, okay, like this. I want you to put the mean in the middle. I want you to go 1 standard deviation, 2 standard deviations, 3 standard deviations, and show me the percentages as well. If you need to go back to the definition at the beginning, you can. So go ahead, pause the video, do the problem. Here's your solution, okay? And this gives it in numbers, not in the chart, but you can see what they are. All right, see you tomorrow.